All right, we're going to take a look here at example number 4 and number 5. These are actually both, though, listed as, well, actually number 4 is just listed as a problem for you to actually try on your own. So I'm going to ask you to, again, pause the video here and see if you can try to work with this particular question on your own first. You want to test to see how well you're getting the idea. So I would ask you to pause the video and think about a way that you might be able to make just a regular old comparison. Try a regular comparison test. Watch it fail, and then you might have a sense of what you might be interested in using with a limit comparison test. Okay, go ahead, pause the video, and then when you resume, you'll see me working through this solution and the solution for example number 5. Okay, so my solution here is going to revolve around the following. I'm going to say, let's consider the series n starts at 1 to infinity of 1 over n. Now, you may have chosen 1 over n, or you may have chosen something like 1 over 2n. There's actually many options you could choose. It doesn't really matter. But I'm going to choose this because I recognize this is the harmonic series, and I know that it's going to have all positive terms, and it diverges. Again, I'll say that both series contain only positive terms. We calculate. I'm going to set up my limit. Again, I can put these in whatever order I want. I'm going to go ahead and put it in this order. Feels like it'll work out nicely. I'm going to end up with a 2n plus 3 over nn. It's going to be the limit as n approaches infinity of, it's going to be 2 plus 3 over n. And so I get 2. Since 2 is positive and finite, we know by the limit comparison test that, well, let me write it like this. Both series converge or both diverge, and then since our series diverges, then the one that we started with diverges as well. Okay. Now, it doesn't necessarily matter if we get the same number back out of our limit. It just matters if we both got a positive finite number. So depending on the way that you do the division over here, or what function you chose, or other series you chose to compare with, could totally change that blue value, which isn't really relevant at all. Okay, let's take a look here really quickly then at example number 5. Example number 5 is going to highlight that times using the comparison test first is not always going to be an easy thing to do, but that sometimes we might just immediately want to jump to a limit comparison. And so again, I'll say take a look here. Determine with justification whether this series converges or diverges. Again, this might be difficult to try to start to work with, but I could maybe start with the following. Oops, I could say, consider the series 1 over n which diverges. Right, there's my nice harmonic series. I can easily see here that both series have positive terms Now, that's actually a statement that's got a lot more to it than it maybe at first seems. Like, clearly the harmonic only has positive terms, but how do I know that the sine of 1 over n only ever makes positive numbers? Can't the sine make positive and negative numbers? But if I notice the values that I'm going to be plugging in, if n is a 1, I get sine of 1. Then I get sine of a half and sine of a third. And I get sine of values that get closer and closer and closer to sine of 0. If I was to think about my unit circle, I recognize that 1, or 1 radian, is somewhere in the range of near like 60-ish degrees. You could do the conversion yourself. But that I'm going to be dealing with kind of moving down this way. And I'm going to be doing sine is going to be tracking the y coordinates of these points. So I kind of pull that blue line down towards that x-axis. So all those y coordinates there are always positive. But now I could go ahead and actually set up a limit. I'm going to go ahead though and first define a function. So I'm going to say, how about we let f of x be equal to sine of 1 over x over 1 over x. Then, when I do the limit as x approaches infinity, I can actually make use of L'Hopital's rule, because top and bottom there are both going towards 0. The numerator is going to be cosine of 1 over x times negative 1 over x squared. Don't forget that came from the chain rule. And the denominator is also going to have a negative 1 over an x squared. That's convenient because these pieces here are going to cancel out, and what I'm left with is ultimately going to be just the cosine of 0, which is 1. So that means that the limit of the sine of 1 over n over 1 over n as n goes to infinity is also equal to 1. And then I can say, by the limit comparison test, we know that the series with that sine of 1 over n must diverge. It's got to do the same exact thing as what we compared it with. And since we compared it with the harmonic, it's got to diverge. Okay. Again, the there is no 5.4 worksheet, but there is a series 1 review worksheet that will have lots of problems that are a mixture of the things we've talked about thus far. These sections can be a bit intimidating and a bit overwhelming at first, but with practice, you can get really good at this stuff. The important thing is to recognize that there's no set strategy. There's not like an exact order or sequence of events to try to run through. But again, we've seen about some standard sorts of things that seem like good strategies to employ. If I want to come to a series that doesn't meet a specific type, try test for divergence right away because it's really easy. If there's something in there that looks easy to integrate, maybe see if you meet the condition integral test. You can always try comparing, and if comparing sucks and doesn't work out well, try a limit comparison. But there's no one right way to do a test. So again, if my solutions look different than yours, it doesn't mean you're wrong. See if you met the right or arrived at the same conclusion that I did, and feel free to pass your work along to me, and I'd be happy to check to see if you did it right. All right. Well, that wraps up all the videos for this week. Please make sure as you're trying to practice as much as you can, there'll be more videos up online available probably some point during and maybe after spring break. All right. If you got questions, I'll see you in office hours.